Hey Jason, I've got a fun topic for today.
What's that?
Non-determinism. This one comes up a lot when I'm talking to developers about AI. We have a great conversation about the cool things AI could do, how they could work it into their application. And then we start talking about taking it to prod and people are like, whoa, AI is non-deterministic.
That's because it is non-deterministic.
Yeah, yes, it is. And that does provide some unique challenges, but non-determinism doesn't mean we can't use it for real software. It just means we need to think about some unique things when we're designing our applications and our AI agents.
So the first step in handling non-determinism in AI is to just set the temperature to 0, right?
No, not exactly. You can adjust the temperature, and that can be an important part of building an AI system that meets your needs. And if you've played around with AI models, you've seen the temperature setting, and you may have tried it and realized that if you made it go lower, the responses were more predictable. But that's not the only solution, and probably not the best solution. Turning down the temperature can stifle creativity, it leads to repetitive outputs, and it makes your AI, well, boring. It kind of gets rid of some of the magic and the value of generative AI.
But if we can't just change the temperature to 0, then where would we start?
For me, the first part of a conversation about non-determinism is determining if you actually need deterministic responses, or whether you just need reasonable responses. The majority of the time when I talk to folks about non-determinism, they aren't actually concerned about non-determinism. They're concerned about the variation in response quality that they can get when using an LLM.
And probably concerned about the difficulties of debugging non-deterministic systems.
Yep, that too. The challenge ends up not being the non-determinism itself, but the results of that non-determinism.
So let's start with response quality. How do we ensure the responses are reasonable when non-determinism means that we don't know ahead of time what the LLM will do?
The solution to that is something that we've actually talked about before in last season. It's evaluation.
That's right. Last season, we talked about the importance of how evaluation works and some basic evaluation techniques. And you can find a link to that video in the description below. But AI agents have tools and more complex prompting techniques. Are there any special evaluation techniques that can help us here?
There are, but we're going to start with one simple one, which is adding evaluation to every step of an agentic flow. So let's use an example. Let's say you have an agent that's making reservations, and I ask for a chain of thought prompt to walk through the steps that might be necessary to make that reservation. Step 1 in that chain of thought prompting sequence could be something like, ask the user for the necessary information and extract that information from the user's response, things like the number of people in the party, any dietary preferences, etc. Step 2 would be something like use the reservations API or the reservations tool to find available restaurants that meet their needs. Step 3 would be to present those to the user and ask them to pick their favorite. And then step 4 would be to, of course, make the actual reservation. You can add evaluation after each of those steps to ensure that things are proceeding correctly as you move along.
All right, so after step 1, we can feed the conversation context and the info extracted to an evaluator to make sure that the AI extracted the information correctly. During step 2, we could verify that the information being sent to the reservation tool is valid and that the data that's coming back from the tool is also appropriate. And then we could do this for other steps, right?
That's exactly it. Adding evaluation early and often in the system can ensure that any mistakes or hallucinations that happen in earlier steps are caught and addressed before they propagate through to the later steps. If the evaluator finds an issue, you could start the entire flow over, return an error to the user, or you could use AI or algorithmic approaches to potentially correct the error so that you can continue with the entire flow.
And you could also use human in the loop to bring into these cases too, right?
Of course, and a lot of systems that don't use generative AI actually already work that way. An example that most folks watching this will know is merging code. Computers have been able to handle some kind of merges on their own for decades. But when they can't handle a merge situation, they do their best, and then it gets sent over to a human with the necessary information for that human to resolve the issue. You could do the same thing in your agentic flow.
All right, so what other options do we have if the evaluator identifies places where our AI agent's behavior isn't up to our standards?
Like I seem to say in most of these videos, it's actually just basic software engineering. You need to assume that the systems you're working with are going to produce unexpected outputs sometimes, whether those systems are external APIs or LLMs. You need to design your agents and applications to catch errors, fall back on reasonable defaults or other error handling, and then return a logical message to the user if you can't actually complete their task.
And I think most folks are comfortable with handling unexpected outputs. And as you pointed out, it's pretty normal software engineering or application development. But I do think debugging non-deterministic systems is a bigger challenge for many of us.
I get that. And I'll be honest, sometimes when I'm coding with LLMs, they do things that make me scratch my head. I've lost hours debugging issues because I didn't understand exactly where the issue was in a complex agentic flow.
That sounds like a logging problem.
That was definitely a logging problem. I didn't have good logging at every stage of my agent flow, and I wasn't logging which tools it was using, what parameters it was sending to those tools, and which tools it was returning. So I was debugging a complex, non-deterministic black box.
Not fun.
It was not fun.
But it seems easy to address. Just add logging at each step of your chain of thought or in your flow. And a lot of AI frameworks and agent frameworks do this for you automatically.
Yeah, in one case, I was actually using an agent framework that logged everything. I just didn't look at the logs. I was in this mind space that I've seen others get into where I thought AI was different, and my standard software engineering skills that I've spent a lot of time perfecting and learning didn't apply anymore. So I just didn't think, oh yeah, logs.
That's a choice.
That was a bad choice.
So you started this discussion by asking, what about non-determinism? And talked about how engineers that are trained on deterministic systems can work effectively with non-deterministic AI.
Yeah, and it turns out that the answer is using techniques that we already know from working with APIs and other external systems. We check for errors and issues each step of the way. We log what we're doing so we can figure out exactly where in a flow an issue was.
That sounds kind of boring.
It is actually kind of boring. A lot of these videos actually just seem to come back to you can use the software design principles you already know with just minor modifications to work with AI. We've put a couple examples in the description blocks below where you can see things like evaluation of a multi-stage system and also how logging can work for a multi-step prompt or an agent.
And with that, this is Jason.
And Aja.
Signing off.
Happy prompting.